Okay, so once you've gotten your initial model and run it out of virtual pulse and you have your energy use projected, a good question is to ask, okay, well, how does this actually compare to other buildings? Is this typical? Is this very far off? So this is just called benchmarking, and we can benchmark our energy model to known data from buildings of a similar type. So for example, if we have an education building here, or an office building, which you might have on campus, we can look at data from other buildings. In this case, this is from the Energy Information Administration, which is a unit in the Department of Energy. And every once in a while, they run the survey called the Commercial Building Energy Consumption Survey. There's one that is currently being released, but prior to that, it was released in 2003, and it lists the energy use intensities. In this case, it's broken down by end use for a bunch of different building types. We are probably interested in education or office buildings, and as you can see, heating use is the biggest component of that, and lighting is as well. And we're targeting energy use intensities, which is a unit of total energy use divided by the floor area. It's usually in buildings, it's not a perfectly linear to assume that as you're increasing in size, the energy use linearly increases, but it's pretty close. So EUI, as it's used, is a good way to compare buildings. And it's one unit of that is kilobtu's per foot squared. If it's SI units, that's kilowatt hours per meter squared. And so we're expecting an EUI generally around 90 to 100 for these buildings. So you can take your energy simulation and see, does it match that? Is it much higher or much lower than that? There's other places you can do this benchmark comparison. The Building Energy Data Book has data on CBEX and from some other surveys, which I showed you, so you can check that out. There's also Energy Star Portfolio Manager and the Building Performance Database. So let me pull some of these up here. The Building Energy Data Book, this is provided by the Department of Energy. They've got lots of different information on buildings. In this case, we're interested in the commercial sector, and we can scroll down to see our consumption intensity, say by vintage of building. In this case, we're looking at education buildings. So we can see, okay, if it's an older building, I'm expecting maybe 80 kilobtu's per square foot. If it's a newer one, maybe also around 80. Portfolio Manager, a lot of building owners record the annual energy use of their building through Energy Star Portfolio Manager. There's a lot of buildings in this database now, and so you can use that to get a bit more accurate estimation, a bit more current estimation of how much energy buildings are using. So in this case, we can say look at office energy use and access that information. And you can see that this is from 61,000 properties, so that's a pretty large sample. And here, this is in source EUI, not site EUI. We've gone over the difference beforehand, but again, source is the total net primary energy, which is including all the inefficiencies that you have from your power production. But you can see that the source EUI is around 184, which is actually probably pretty comparable to a site EUI of, say, between 80 or 100. The last piece I want to show you is the Building Performance Database that Lawrence Berkeley Labs put together. And so you can get a bunch of different information. They have here a data set of about 45,000 buildings that you can draw from. So we have a bunch here, but we can, say, specifically look at college or university buildings if we want, and then just focus on the site EUI and compare those. And in this case, it'll give out, say, site EUI for just different floor areas here. And we can use that to sort of construct a bunch of different comparisons. As you see here, there's much fewer buildings than the initial 45,000. So you have to be a bit careful when using this just to make sure that your sample size is large enough to make for a valid comparison. This is also data from across the United States, and we're particular to the Mid-Atlantic region here at University of Maryland. So that may also give different answers.